Alright, so we'll finish number 3 right here, and it's the same method as the other two. We always start by seeing if there's anything we can factor, and we can factor this right here. What multiplies to negative 24 adds to negative 2, that would be a minus 6 times a plus 4. And then our least common denominator, well, clearly we need an a plus 4 because all of those have a plus 4 in them. And we're also going to need an a minus 6. So that will be our least common denominator. That means that's what we're going to multiply everything by. So that should be an a plus 4. A plus 4 times a minus 6. And on the other side, the same thing. We're going to multiply by a plus 4 times a minus 6. Alright, so now we're in a position to distribute. So if we distribute to this first one, those cancel, and so do those. So what we're left with is this right here. So we have a squared minus 6a plus 8, and there's a plus sign right there, so I'm going to put a plus there. Okay, now if we distribute to this far one right here, the a plus 4s will cancel, but we're going to have a minus 1 times that a minus 6. Those will not cancel, so those need to be multiplied. Okay, and then lastly, on the other side, we will have we'll have an a plus 4 canceling, and we're going to have a minus 6 still left over times that 1. So a minus 6 times 1 is just a minus 6. Okay, now you might be able to recognize this. This is now a quadratic equation. It has a powers of a being squared. So let's do a couple things. First of all, let's subtract the a from both sides, and let's add 6 to both sides, because whenever we're solving a quadratic equation, if we want to do something like factor or anything similar, we have to do that by putting it in standard form, meaning set it equal to 0. Now we can FOIL this right here, so a times a would be a squared minus 1a, and then the outsides would be minus 6a, and then negative 1 times negative 6 is positive 6. We have plus a squared. This right here, minus 6a minus a would be minus 7a, and then 8 plus 6 is 14. So let's simplify this. We have a squared plus another a squared would be 2a squared. We have minus a minus 6a, that's minus 7a, minus another 7a right there is minus 14a. And then 6 plus 14 is 20. Now you might look at that and say, well, we'd have to factor using the swing method or something similar, but we don't, because all of these numbers are divisible by 2. So let's just divide them all by 2. So we get 0 equals 2a squared divided by 2 is right there. 14 divided by 2 is 7. And 20 divided by 2 is 10. Now what multiplies, we can factor this now. What multiplies to positive 10 but adds to negative 7? That would be a minus 5 times a minus 2. And if we solve that, we get a equals 5. And if we solve this, we get a equals 2. We should plug them both back in right here. I will leave that to you to check it, but I have checked it already. And when we plug both of those in, we do get both of those answers being valid. Neither of them are extraneous. Here's what an extraneous would look like. Let's say you plugged in a equals 5, for example, and the right side or the left side were equal to 1/3, and the right side came out to be negative 1/3. Well, clearly those are not the same. So that would be an example of whatever you plugged in would be extraneous. Okay, but that's not what happened in this case. If we do plug them both in for a, we wind up getting something true in both cases.